Good morning, ladies and gentlemen. We are here today to discuss cybersecurity. Cybersecurity is quite a long word, but it's also quite a complex topic. And with us here today, we have three people that are going to help us understand what this concept is and what it means for the actual power generation industry, because it's one of these terms that is a catch-all, and it impacts so many industries that we have to really look at our vertical and understand what is actually going to happen and how we can help prevent and help position ourselves in a cyber secure situation. So with me today, I have three super experts that are joining, and they're going to explain from their different point of views what they're working on in cybersecurity, and they're going to give you a really good understanding of how it goes. So first of all, I'd like to welcome Jan to introduce himself. Introduce yourself, please, Jan, for me, and tell us where you're joining from. And remember to take, yeah, perfect.
Okay, so hello, everybody, and thank you very much to you, Belen, and to your team for giving me this opportunity to present in such a webinar. So my name is Jan Bartosz. Right now, currently, I'm joining in from Prague in the Czech Republic, but until very, very recently, I was working for the International Energy Agency. So that's an agency based in Paris. I don't think I need to introduce it to most people who are working in anything related to energy. And I was mostly specializing on energy security and giving emergency preparedness advice to our member countries. And of course, very recently, the theme or the focus of everybody is cybersecurity and more broadly digitalization. So in the International Energy Agency as well, we started looking at all the different aspects of digitalization and what it means to energy. And of course, one of the topics that we needed to look at was the risk that digitalization brings to energy. So this is where I contributed, and I co-authored a chapter in a report that I will present later in my presentation, Digitalization and Energy, and I co-authored the chapter on risk and resilience. So this is, I think, why I was invited to this webinar.
Indeed, you know, we all heard about Ukraine. Thank you very much, Jan, and we're going to go introduce everybody else, and then we'll begin with your presentation. Christina, would you want to please introduce yourself briefly and tell us where you're joining from? By the way, Jan is joining from Prague today. Christina, yeah.
Hi, everyone, and thanks also to Belen and to all the team for calling us and giving us the opportunity to talk. My name is Cristina Marzal, and I'm joining from Madrid, Spain. I work for PwC, which is a large consultancy firm that tackles many different problems worldwide, and I specifically are part of the area that covers security and risk. So we, our team gathers many different experts from different companies and many different backgrounds in order to design solutions for companies, organizations that are affected by specific risks and need to develop models on how to tackle them. So this is a bit how the presentation is thought of today, and this is the outlook we'll try to present.
Thank you very much, Christina. I'm really looking forward to hearing both your presentations. And Santiago, last but not least, please introduce yourself shortly and where you're joining from.
I'm Santiago. I'm from Bilbao. I'm working as a cybersecurity researcher in Tecnalia, Research and Innovation. I work in the cybersecurity department, and my focus on investigation are mainly, well, it's cybersecurity in general, and I'm focused on critical infrastructures and blockchain technologies. What we are doing here in Tecnalia in cybersecurity, for example, is we try to adapt technology to different necessities in the companies, and we try to generate some knowledge about cybersecurity and different topics in general, but mainly in my case, of course, cybersecurity.
Thank you very much. You've said two big words there, cybersecurity and blockchain. I suppose there is a relation that we will actually find out when we hear your talk. But without further ado, you know, you've already heard the introduction, so I'm going to ask Jan to please share your screen, Jan, and he can begin his presentation. And in the meanwhile, while he prepares his presentation, I'd like to ask you guys to one, share with us where you're joining from through the chat. Make sure that you tag all panelists, and also to make sure you send us your questions. There is a Q&A box at the bottom in your toolbar. You can send your questions through there, and once the 3 presentations have gone, we will actually go back and answer as many as we can, so please send those through. Without further ado, Jan, just unmute your microphone for me and you're ready to go. Can you unmute your microphone, please, Jan? Just take the mute off. Yeah, it happens to me all the time, and I do this all the time, so don't worry. Let me see, maybe Araceli, can you help? Yeah. We'll unmute it for you at this end. Okay.
There. Okay. I just, yeah, sorry about this. When I put the presentation on full screen, I lost the little icons with the controls of the mute and unmute. So sorry about that.
We can see your presentation perfectly, so you're ready to go.
Great. Okay, so let me begin. So thanks again for giving me this opportunity. I think my presentation will be something as an introduction, or that's how we discussed it with the others, giving an overview of the topic, and then Santiago and Cristiana will dive a little bit deeper into the issue. So let me go to the next slide. So this is just by way of introduction. I already mentioned this, the report, Digitalization and Energy. I think I'm no longer related to the IA, but I think I can give my word for this being a really high quality report and a nice introduction to everyone who wants to give a read to not just issues related to security, but this is a nice report that gives an overview of what the new era of digitalization brings to the energy, to energy demand, to supply. What are some of the key trends that can be identified? What will this mean for the future of energy? So if you're interested, just go to iea.org/digital and you will find a nice mini site, and you can download the report for free. That's to say that most of the reports by the IEA are for free. Go there and have a read. So with that, let me go to the first real slide of my presentation. I think I would like to begin saying that digitalization brings many opportunities. It's not just the risk that we're talking about today, but it brings changes across all energy sectors, digitalization, and opportunities mostly. I think most of our audience today comes from renewable energy companies. Unfortunately, of course, the world is still stuck and will be for some time with other types of energy, such as oil, gas, and coal as well. So we need to stick with the dirty stuff as well. But digitalization actually can bring some improved environmental performance even in these sectors. So that's good news. I think most focus today also is on electricity, because that's where the most digitalization happens, and that's also where a lot of the risk is coming from. So of course, digitalization brings added risk, which is why we're here today to talk. One important thing that I would like to mention is it's not, the risk doesn't just come from malicious hackers. When we say cybersecurity, most people imagine this guy somewhere behind a computer, which is of course a lot of the risk as well, but it's not just attacks, it's also technical incidents. There's a growing interconnectedness of all the energy world, the devices between facilities, sites, and so on. So all this increases the surface where a technical incident can happen, but also I would like to mention natural events such as geomagnetic storms, which are of course affecting digital devices, and as digitalization progresses, the risk stemming from these events is much higher than it used to be couple of decades ago. Another important thing that I would like to mention is energy is a very particular sector. It underlies all the other sectors. Lives, health, order, properties depend on it, and it can't simply be shut down. You cannot just simply shut down your electricity network, reboot it when your personal computer is hacked. So it requires special treatment, I should say. There was a recent increase of incidents, this is for sure. We keep reading or hearing about it on the news. There were many incidents, some targeted, some generic. This is a big distinction. Targeted, I think many of you have heard about Stuxnet, this virus deployed in Iran against the nuclear program. We can also mention the attacks on the power grids on Ukraine. So these are examples of attacks that were specifically targeted on energy, on power grids or on energy infrastructure. But even the generic ones, such as the recent outbreaks of ransomware, such as WannaCry, can have and did have significant impacts on energy companies as well. And not just on their economics, but also on the actual security of supply. We, for example, have heard of a case of a company in China that lost all the petrol stations' capability to control petrol stations because they were affected by this virus. So another point that I would like to make is, of course, it's a hype word, cybersecurity, but so far, actually, the damage that's been caused by cyber attacks or incidents is relatively small in scale so far when compared to other types of disruptions, such as hurricanes or geopolitical incidents, events that, of course, we all know how geopolitical events, for example, affect supply of oil. So that's one line to make. So for both governments and companies, I think I would like to mention that there's an importance to take an all-risk cross-sectoral approach and not just focus on one particular risk just because it's a hype word. That being said, attacks are becoming cheaper, they need less sophistication, the attack surface becomes larger with this spread of technologies. So of course, the risk has a tendency to increase. So what trends to watch? I think I mentioned diversification, decentralization. We have the Internet of Things, we have the interest in the Internet of Industrial Things, we have the Internet of Energy. So we have millions of small-scale prosumers, billions of devices. So all this increases incredibly the surface of attack and where an attack can happen. These devices, they can be either directly hacked to take control over them. I think you can, for example, imagine smart kettles to boil water in households. If they are all powered at the same time by a malicious doer, so what this causes to the grid, or they can all be taken control of and turned into a weapon against something else. So the so-called botnets, and this already happened as well. Geographic diversity of internet, that's for sure. Everybody knows internet is global. Companies also, some of them are global. So there is no such thing as an attack, targeted attack. The malware or the virus can always spread and will spread out and will cause damage, not just where it was targeted, but it could be all over the world. And the cases such as the attacks on Ukraine, where global companies such as Maersk, for example, were affected quite significantly. And of course, they were not the primary target. Primary target was Ukraine and Ukraine society. So this is an important thing to mention. What I mean by changing technologies is, the energy sector is not new to information technologies. We have SCADA systems, for example, for decades. but many these big companies have had proprietary systems for a long time. And it was quite difficult to, and you required a high level of knowledge to be able to get into these networks and to control them, to cause some damage. So this is what's called security, what we can call security by obscurity. It's really difficult to get into these types of technologies or network. Today, of course, we are losing this type of security because there is much higher level of connectivity, automation, cloud computing, security is being delivered as a service. So this can bring a much higher level of security, but there's a certain level of standardization. So it can mean that there's a higher probability of a bigger attack. And of course, the risk of low probability, high risk scenarios, which could shut down the entire an entire system for days and weeks, is something that needs to be taken very seriously, especially by governments. And for smaller companies, there is more this risk of an increase of nuisance attacks from botnets, which cause money but don't really cause severe damage to the networks. So what to do, how to increase resilience. I think the key precondition is that all actors need to be aware of the risks. This is raising awareness, what we are doing right now, but what we've also tried to do at the International Energy Agency, raising awareness about this theme. Simple maintaining of what we call cyber hygiene, updating your systems, patching, training your staff, and so on. There is, of course, building resilience into the system, but also taking into account that you can never prevent 100% of attacks. So you need to be sure, especially in critical infrastructure, that even if you take a blow, you have the ability to adapt, to withstand the shocks, and to recover quickly, to deliver at least some basic service and to preserve continuity of the critical infrastructure. So you need policies and protocols for this. Cybersecurity needs to be mainstreamed into research, into development, into deployment. It wasn't so in the past. So you need to think when you're designing a device, controlling a piece of equipment in your power network, you need to design it with security already in mind and not hot patch it after it has been designed and installed. I think I'm slightly running over time, so I will try to speed up. I won't talk about standards, or but I think I'll mention international efforts, because that's what we're also trying to do. Organizations that are not specifically technically dealing with cybersecurity, but can also help in spreading best practices, or helping put the right people together, such as for example, the organization where I used to work, the International Energy Agency. So this slide is just showing the obvious, that most companies can handle the smaller types of attacks, but as the attack becomes more and more sophisticated and larger in scale, there needs to be some sort of intervention by the government or by some specialized organizations. So it's about finding the right balance and designing the right type of policies, about defining these borders or these definitions. Most countries already have cybersecurity high on the agenda. They have specialized institutions to provide real-time analysis and information, threat information. They have catalogs of minimum IT standards for their energy companies. There's supervision in the European Union. For example, the recent NIS directive was launched. And of course, most important in preparedness is exercises. And of course, this is also being done both in all over the world, on a more global level, in North America, EU level, but also in the level of individual countries or groups of countries. The Nordic countries, for example, have a nice series of exercises. So I think there can be some no regrets policies that can be identified. I won't go through all of these for the sake of time, but of course, the most important I would point out is building digital expertise within all staff, talking about organizations, state institutions, companies, ensuring that you have access to timely, robust, and verifiable data in your company, building flexibility into your policies when you're accommodating new technologies and developments, and so on. So the key message is raising awareness is crucial to defend against cyber risks. Everybody needs to work together proactively to manage the increasing complexity of threats, and digital resilience should be mainstreamed into policies and into market frameworks and into research. So that's about it for me. I apologize for running a little bit over time, I think. Thank you very much. And of course, I'm available for any questions, either now or later by email or LinkedIn or whatever.
Thank you very much, Jan. You did a little bit over time, but you did really well, and also it was really interesting. So I think you did famously. So if you can just take your screen off for now, and the questions, just perfect. And now if I can ask Santiago to share your screen and unmute your microphone as well, maybe the other way around so you don't have the same problem. Again, questions for Jan, for Santiago, and also for Christina, just send them through the Q&A box. We catch them at the end. There is so much happening, I think so much disinformation, and I think the media is also chasing its tail, so we don't really know what's going on very much. Are you ready now? Yeah, we can see it perfectly, Santiago.
Yeah, sure. Okay, yes. Perfect.
Yeah.
Well, first of all, I'm Santiago. You have my contact details on the right the slides. I'm talking about cybersecurity risks mainly. I'm talking about cybersecurity applied to just power generation industry mainly. First, I'm going to show you in this scenario, what we have here is a lot of connected devices, or less all of them are connected, and all of them are transmitting information. So what we need to do is to protect these communications as well as we do in normal or traditional networks. So first of all, we need to apply good practice in cybersecurity over these devices, first to protect them. And of course, all of these devices are using old protocols, mainly they are industrial protocols with no service security in mind. So we need to apply ciphering techniques over them. At the end of the presentation, I will share some basic countermeasures we can take to protect these systems. But now, I want to show you the landscape we have, okay? And of course, we have all of these devices are from different manufacturers. So we have a lot of devices just transmitting information and from different manufacturers. So when we try to gather of these into a single infrastructure, we will find that there are some vulnerabilities, or it appears some vulnerabilities that they are not easy to fix, because it's complicated to find the source of the vulnerability, because we have a lot of different devices from different manufacturers. Okay, all of these devices, in addition, are user-friendly oriented. What I mean that all of these devices are implementing or has been implemented to be easy for the users to manage. Okay, and if they are easy to manage for the users, are easy for the attackers to attack them. Okay, so most of them, in my experience, okay, most of them don't have a proper access control strategy implemented in them. Okay, I will go deep into that later, but just keep it in mind. And of course, we are seeing from industrial networks to digital networks. So we need to apply, or we need to implement all the things, all the knowledge we are learning in normal networks in cybersecurity. We need to apply it to these networks now, because we are living like a transition between two worlds, the industrial world and the digital world. Okay. And in this case, in the case of power generation industry, the scenario is becoming even worse. Why? Well, I have here four aspects I consider they are really important. First of all, in traditional scenarios, we need to prioritize confidentiality over availability. But now here, it's more important availability, because all these systems need to be connected all the time to the network. So we cannot just disconnect them from the network. In traditional networks, if we are suffering an attack, we just disconnect the devices from the network, everything is fine. But here we cannot do that, because if not, our users don't get any energy. So it's important to get availability rather than confidentiality. And of course, we are dealing with electrical, industrial networks. So mainly we are losing efficiency in the backup strategies, because we can have a backup of our IT infrastructure, but we cannot have a backup of the whole infrastructure with the industrial network. So it's really complicated to establish a backup strategy. In addition, all these systems usually work with a response time really, really short. What I mean that they are more vulnerable to the negation of service attacks. And of course, every security measure we try to apply over them, it's going to affect our latency. Latency is going to be high and performance is going to be low. So we have a problem here. We need to be really careful when we choose the kind of cybersecurity measure we want to apply over these protocols because of that mainly. Another aspect is the sophistication. Attackers are really well prepared, and they prepare tailored malware, prepared especially to target these systems. So it's really complicated to protect them, because it's mainly zero-day malware, and it's specifically prepared to target our system. So they are really well prepared, and by contrast, we have really low prepared defenders. There is a lack of expertise in the defender. So the balance is really biased against defender in this case, okay? And in addition, last but not least, we have critical infrastructure. I mean, these infrastructures we are talking about are considered as critical infrastructure. So they are a target for government. There are governments involved in targeting this. And of course, they are targets for IPTs, which are advanced persistent threats. An advanced persistent threat is like, imagine I'm an attacker and I want to perform one of these attacks. What I'm doing is I'm trying to break into the system again and again and again and again. So I have all the resources I want. I have all the time I want. So actually, I finished entering in the system. I finally achieved my goal. So this is what is called an advanced persistent threat, and it's one of the most dangerous ones, because you suppose that the attacker has all the resources to perform the attack. Okay. And here, what I have for you is a pyramid of risk. In the level 1, it will be anyone, could be mine, could be you as an individual. In the level 2 of risk, we have normal companies like financial companies, technological companies, NGOs. And in a level 3, we have government, high-plastic companies, defense institutions, and critical infrastructure. Remember, we are a critical infrastructure, okay? And level 3 and level 2 are targets for APTs. Here I have some threats. I don't want to go deep into these threats because it will take me a lot of time, but mainly what you need to remember is we have 4 cybersecurity requirements, 4 main cybersecurity requirements, which are confidentiality, integrity, availability, and non-replication. And we need to keep all of them, but mainly remember the slide before, availability in this case is even more important than confidentiality, okay? For example, here, if you see the diagram, you can find denial of service, for example, as a threat, which attack availability of the system, for example. If you want, or if you have some questions, you can just ask me later some of these attack vectors, and I will answer you with more time, okay? But just because you have here the diagram and you can see them more easily. And now I'm going to present you some basic countermeasures you can take to protect your systems, okay? The countermeasures are really similar than the ones you can take with normal systems or normal networks. First of all, you have free and commercial products, like for example, could be IDS, like intrusion detection systems. You have firewalls, you have SIEMs and honeypots. Well, an intrusion detection system, for example, is like a device you put, it could be, for example, a network detection system. It's a device you put in your network and it prevents, it detects when an attacker is entering in the system. If you can program it before, and you can let it learn over the time to try to discover if there are attackers or not in the network. A firewall is another element really important, and what he's doing is try to reject or to expulse attackers from the network. And they are usually much more common when you use them in combination with an IDS. So IDS detects the attacker, firewall expulses them from the network. okay? Honeypots are like fake systems. They are designed to fool the attacker. So actually what is happening is the attacker is trying to break your system and he thinks he's attacking the real system while he's attacking a fake one. So in the same time, you can learn knowledge, you can learn about his behavior, and you can prepare your strategy for defending your systems. For example, you can train your intrusion detection system with the information you get from the attacker, for example. Another basic countermeasures, I don't want to go really deep, is protecting communications, strong passwords, implementing correct access control, hardening. Hardening is mainly updating your system and keep them secure, okay? And training. This is really important. I left network segmentation for the end. Training is really important because you need to train your employees, because if not, they can suffer social engineering techniques, so they can be attacked in this way. And network segmentation is really important too, because if you don't have a proper network segmentation, an attacker can get into your network, can break into your network, and can take, for example, a device and can press along the network, so it can take the rest of the devices in the network. So you need to implement a network segmentation. In my experience, you will be surprised how many networks don't have a proper network segmentation. Okay, you need to implement it using routers, switches, this kind of stuff. Okay, with all of this, you build your use case, you prepare a combination of all of these elements, and you build your own use case, and you plan the security policy of your company. And what can you do if everything fails? Well, you always have your disaster recovery plan. A disaster recovery plan is a plan you prepare just in case something terribly bad happen in your organization. For example, imagine an earthquake. Obviously, all this stuff doesn't fit for you, so you need to have a disaster recovery plan, and it's going to help you to improve or to gain resilience in your system. Okay, and here I have for you screenshot. This is an intrusion detection system. This has been developed in Tecnalia. For example, for us, it is a normal intrusion detection system. We are going to apply or to implement machine learning over it, and it's useful, for example, to detect potential attackers in your network. And now, in 1 minute, because I think I'm talking too much, I'm going to talk about blockchain as a infrastructure or as a way to protect our system. It could be a countermeasure, and we are going to discover why and how. Okay. Well, blockchain mainly can work as a background infrastructure. Okay. Think of blockchain, for example, as a database. You can use a background interface to connect all your devices. Mainly they are IoT devices. You can connect all of them, and you have a background infrastructure. What does it mean? It means that, for example, remember when we were talking about we have different manufacturers. Well, with blockchain, we can solve this issue, because even if we have a lot of manufacturers, all of them are using the same infrastructure to transmit information. So we are solving, for example, this problem. Okay, and of course, blockchain can guarantee traceability, integrity, confidentiality, and non-repudiation. Okay, and as you can see, if you want more information about blockchain, you can ask me later and I can answer you. And finally, blockchain can be really useful, and this is really disruptive. It can prevent an incoming attack by comparing logs. What is that? Well, when an attacker enters in our system, the first thing he does is he tries to delete all the logs in our system. So what we can do is every time we generate a new log, we just save it in a blockchain, okay, like a database, okay? So when an attacker delete or remove this log, the system administrator can say, okay, I see a log has been deleted because I have a solid background. I have my blockchain with what is saying, okay, I have this log, and I'm sure I have this log because it's in blockchain, okay? So I can see, okay, there is an attacker in my system, so I can prevent myself. I can expulse them from the network much faster than if I wouldn't have this technology. Okay. So, well, I have a screenshot here for you. This is a blockchain explorer, but just for curiosity's sake, for me, I think it's enough. I think I didn't talk too much. I tried to go fast, but if you have some questions, you can just ask me something and I will try to answer you in the way I can. Okay. So thank you all of you.
Yeah, I suppose, we're talking about cybersecurity, so perhaps no one should ask questions to us directly here in the chat. So you should ask them directly to them. So you have their details, and if you don't, then we can send them to you. Sorry, do you have anything else to add, Santiago?
No, nothing. I think it's everything for today for me.
Thank you very much. So Christina, now it's your turn. Please share your screen and go ahead.
Okay.
Can you just make that large?
There we go. Yes.
Yeah, perfect.
Well, hello everyone, and good afternoon if you are near where we are. We have already talked about the two sides of cybersecurity. Firstly, the big picture, which is what normally policymakers see. Then the actual technical side of it, from the point of view of the people who developed the tools to fight the threats. And now, just to finish the circle, I'm going to speak more about what companies do to actually, from the management side of view and governance, to counter these threats. Okay, so I wanted to give a slight overview of how this is managed. We don't have a lot of time, so it will be just based on one case, okay, which is how to see cybersecurity from a GRC point of view. GRC, just for those who are not familiar with it, is a common model with which risk is governed. So say risk is seen from the top of an organization, and it is understood in order to give the top-down decisions that will counter or mitigate the risks that have been detected. So it comprises knowing the risks the company is facing, then deciding what is going to be done to counter these risks, what we understand as governance of the company, and also complying with any regulation, internal or external, that needs to be taken into account regarding these risks. Okay, so for this case specifically, I will just change the order of the letters a bit. We'll start discussing what the risk is from the company point of view. Then we'll go to see how this risk has been interpreted by regulators to design the compliance tools that need to be taken into account, and then how this shapes into governance. And I will present a model that is pretty popular right now and that may be of interest for those who may have to in the future tackle this in their companies. Okay. So you will see many points that are in common with the previous presentations here, basically, and just to make this clear before I go on, risk needs to be different from the concept of threat. Just as a threat is a potential or a foreign bad result or bad thing that can happen to a company, the risk is not that. The risk is the appreciation that the company does, considering the likelihood of the threat and also the effects that that threat can have on the company if it is materialized. So it is the risk notion is comprised of many different variables. It is the environment. It is also the dependency of the company in the assets that can be harmed by that threat. And it's also any vulnerabilities that they may have and that may make the effect higher on if the threat actually takes place. So in the case of the power generation industry, we have the three represented, and the three generate a very high risk. Firstly, the society is growing more and more dependent on electric supply. The current studies in the matter, they point at a growing tendency in the future. Some even say that there will be around a 40% increase in the demand of energy by 2020, which means that if now we are dependent on energy in the future, this will be much more sensitive for the consumer. Also, this is joined to the fact that, as Jan and Santiago were explaining, the industrial systems in which such companies base all the critical operations are not so well thought from a security point of view, meaning that initially they were not built or designed thinking that in the future everything would be as interconnected as it now is. And now they need to adapt somehow, and this is where people are working very hard. But until this moment, vulnerabilities still exist, and they still pose significant threats for many companies and subsequently countries. And this is also aided by the fact that the environment is not getting better regarding threats. Cyber weapons are being developed by nation states, by non-state actors, by organized crime rings, because they can bring many quick benefits to many groups. They can bring money in ransoms for organized crime. They can stop the machines of a hostile country when two countries are not understanding each other. And therefore, this creates an environment that poses many threats for this kind of systems. So this, of course, has been noticed. And before we go on to assess what the regulators have made of this risk, I wanted to stop for a quick minute just to be pushing a bit more into the concept of OT, which is something else also introduced in the previous presentations and is the key to all of this. We understand this as the technology that joins the software and the person who is operating with the actual machine that is executing the processes for the company. As we said before, this technology was not so connected, so it wasn't as easy to actually access it. Now it is standardized and it is connected. So the scenario of someone like we see here from miles away assessing one of these systems and perpetrating an attack becomes more and more feasible. Okay, so having said this, obviously, organizations, governments, and industry standards have not overlooked this, and they have created many normative bodies or references. Some of them come as obligatory. In the case, for example, of the EU, this is the NIS directive that Jan spoke about, which creates new obligations that need to be covered for governments and also companies. But also many models that are applied sometimes willingly and sometimes because of inner pressure from, for example, the board, the investors, or stakeholders that have very high stakes on the fact that a company keeps running and they don't want to lose that stake because of an incident. We will just stop in two of them. First, COVID-5, which is a model created by, we could say, the largest industry association for cybersecurity, which in one of its principles speaks about holistic approach. One of the trends now is more focused on attacking this issue as a whole. So before, we could see in many companies that physical security was tackled by a group of people, and then IT security was tackled by another group, and then OT security or industrial cybersecurity, maybe, but even a third. So now the tendency is not to necessarily merge these teams, but to develop a model in which they work as a team in themselves, as they understand each other's vulnerabilities, they share information, and they are able to react jointly if an attack takes place, which is essential for recovery and also for detection, since sometimes it's not that easy. And then I wanted to stop a bit on the NIST framework for industrial cybersecurity. As we see in point 5, that it speaks about recovery. And this is a point that has been touched by Santiago as well, and it's crucial. The fact that for these industries, cybersecurity doesn't mean as much protecting information, which is also important. Of course, the information of the companies is always relevant, but what is going to harm more and to create a bigger issue immediately is a lack of quick recovery of the service. Okay, so in order to achieve this, one of the main models that has been developed until now is called ESRM, developed by ASIS, which is another large industry association, what it has done is pretty simple, but it's also pretty effective. They have taken a classical enterprise management framework, which is used and standardized all over the world, and they have given it a thought from the point of view of someone who manages and governs security. So what they have done is they have put the focus in two aspects that we can hopefully, if it's well designed, see in this chart. Firstly, prioritization. The company is forced to give it a thought and identify all the assets, processes, and information that are crucial for its goals. And once this has been identified, they have to define which ones are more crucial than the others. And this is done because obviously the resources of a company are finite. They don't cover everything, and they need to make sure that the right assets and threats are being responded to first. And then the other large aspect of this model is the fact that great emphasis is done on audit and control, meaning that it is not enough for a company to say that they're doing something or to tell others to do it. Now they are increasingly expected to proactively and responsibly make sure that every single actor that has responsibility for cybersecurity is doing their part, because if something goes on and a blackout takes place for a whole day, the responsibility will still be there, and it is better to add this into the current model. Okay, so just to wrap up, here are 6 concepts that I think are crucial and can also summarize my colleagues' talks. Firstly, cybersecurity is a key issue for the power generation industry for all the reasons that we spoke about. This is largely defined by how OT generates more vulnerabilities and risks than some other networks or systems. The disruptions in this industry affect society directly, so they generate very high impact in terms also of reputation and can severely harm a company. This is why the post-incident recovery is a key aspect to focus in when you are designing your own security model. And also, this is why you need to have a team or a service in which you ensure that you have highly specialized skills and staff, because technology is evolving really fast, and people really need to understand what the company is facing in order to be able to overrun those who are trying to harm the company. And this current trend points to 2 types of profiles: people who are very expert about a specific technology or specific security, but who also need to have the holistic view of what the threat looks like from each point of view in order to be able to respond effectively. And with that, I think, Belen, I'm good on time. And
thank you very much. You're perfect. Thank you. Can you just take your screen off? And so Santiago has been like answering away.
Yeah, I'm a little bit busy. Sorry, I'm writing all time, so let me be concentrating. Thank you.
So you're just going to concentrate on the questions. Okay, that makes sense. I have a question for you guys. This is, I suppose, my own, but it also comes from actually seeing what people are asking there. And is if you are a small company, okay, you have a variety of devices, you have information. What is the most likely thing that is going to go down? For example, is it the computers, is it the servers, is it mobile phones? Because in a lot of companies, they tell me, for example, that they don't use certain makes of phones because, particularly coming from a certain geography, let's just say, because they think that those can be hacked, or they're doing like espionage already. So I just wonder, is there like a weakest link in a system that small companies can? Okay, it looks like Jan wants to answer it, so go for it, Jan, and then I'll give the chance also to Christina.
Thanks. So I think you're referring to quite the question from Javier Guillo, who was asking about what's the main risk. And of course, Santiago and Cristina can give a more detailed and more technical answer, but I think, so the key vulnerability is always us people. It's not the technology, it's us who are lazy about changing our passwords. It's us about sticking I think we all are. Sticking a flash stick that we get on a conference into a computer that we shouldn't do. So no matter how well you design a system, I think you always need to start with training your staff, and comes true, I think, both for a small company and to a large international organization or a big government organization. If the people that are working in that organization are not aware of these risks, then they tend to make many more mistakes, or they don't take it as seriously. So designing a program of, as I was mentioning in my presentation, cyber hygiene. So telling people what are the risks, what is the right type of behavior, setting up a contact point to whom they can report any type of strange behavior, how to identify, and you can have trainings for this. For example, you can get fake spear phishing emails, and the employees in the company should be able to identify that this is an email that's trying to get their password or get their bank data or whatever, and they should be able to report it. And if they don't, it leads them to a page which says, well, this was an attempt to get your personal data, and it could provide access to a malicious hacker into your company's network. Please pay more attention, and these are the steps that you should pay attention to, how to identify these types of emails. So I think my answer is the key vulnerability is always the people working in the organization, and then you need to of course, distinguish between smaller companies and bigger the operators of critical infrastructure, where the type of attacker will always be different, or usually be different. Just one more thing I would like to add is, and this was one of the last sentences in Christina's presentation, which led me to the concept of stepping out of silos. I think you have IT specialists, you have OT specialists, you have company security specialists, and then you have the board, and everybody is looking in their tunnel, this is not how it should work, and all these people should get together and think about a whole concept for their organization perspective, whether it's a small company or a big organization. And so I hope that answers at least a little bit, and happy for if the others want to build on this.
Yeah, I was just thinking that, that prince that keeps on telling me that he wants to send me money, it's my problem from replying back, not my phone, not my, and you're still getting this. I mean, I can't believe these things work, but somehow they must work, because I'm still getting them. I mean, they're a little bit cleverer now, but not by a lot. Christina, did you want to add something, or?
Yes, I will largely agree with Jan. And well, this is actually asking what the most vulnerable part of a company is a bit tricky, because normally when experts go to a company, depending on how it is set up, they tend to find more vulnerable points here or there. But if I had to point a consensus more or less now in the security industry, is that the weakest link is always the user, so the human factor. Because even if you protect a lot a system from the technical point of view, if a user is not made aware of what he can and cannot do, because he has been granted access to that network, he can easily be tricked into social engineering attacks, like Santiago was saying.
Yep, thank you very much. If you're interested, there is a very interesting episode of Reply All, which is a podcast that actually, like, a bunch of nerdy IT type guys try all kinds of things. And one of the things they tried is to have a hacker hack into the system of Reply All, which are nerds. All of them are nerds. They managed within 24 hours. So, and it was a phishing email, so just look into this, because it's actually more difficult sometimes to, if it's, sophisticated, I suppose. And Santiago, if I may ask you, you've been replying all the questions, so because we only have a few minutes, can you give us a little bit of an understanding of what are people asking, what are you replying, you know, just generally?
Yeah, people just wanted to know, for example, what is an IDS or what can blockchain help us to protect? And I just was, because I prefer to write and prepare an elaborate answer rather than saying some words. So this is because I was every time writing in the computer. I mean, I thought it was four questions about IDS, blockchain, and mainly, I think I have them I can search for them actually. One of them, yeah, here. Yeah, the first one was why would an attacker delete logs? Well, because he doesn't want to be cut, mainly, okay? Logs say he has been there, and the first thing he does, of course, is try to delete them, because if not, he's going to be cut later, and if there is a forensic process, probably he will be cut. Okay, so this is the question. This is the answer mainly. How can blockchain guarantee confidentiality? Well, because blockchain can guarantee integrity by design or by default, but you can apply a ciphering over this layer of integrity, this layer of integrity, and you can get confidentiality. Okay, this is because blockchain can guarantee confidentiality. What are the types of intrusion detection systems? Network intrusion detection system and host intrusion detection system. You can say that they can be rule-based if they are based on rules, okay, and they are anomaly-based if they are based on anomalies, but this is another classification. I just prefer the first one, okay? And I don't know. The next one was answered by Jan, and the last one was about it was how can we use blockchain, if we can use it just as a message queue or something similar, and I just elaborate another answer.
I have to say that blockchain right now seems like the hero of the day. You know, it's going to fix our banking system. It's going to make me rich. No,
I'm getting red.
If you guys are interested in this, actually, there is also a lot of episodes about crypto kitties, which is like these really interesting crypto pets technology that is developing. There's all kinds of crazy stuff out there, and they just raise billions and billions. Millions and millions actually they're becoming a unicorn. So there's all kinds of crazy stuff going on in the blockchain world there.
Yeah. If anyone has more questions, they can just write on my email and I will try to or call them, or I don't, you know.
Excellent. So that's my last message to you guys. These are our three speakers. They're all very knowledgeable and they're experts in this topic. You have their email address, they're on there, or just get in touch with us and we'll put you in touch. Thank you very much for being here. Thank you very much, Santiago. Thank you very much, Cristina and Jan as well. It was a pleasure to have you here, and we're looking forward to the next installment where we go to the next level. Hopefully we won't have another Ukraine in the middle. So, you know, we keep on learning about cybersecurity, and thank you very much to everybody who's here, and see you next time. Thank you. Bye.